Hello everybody, get ready to do lesson 2.8 part 1 of your pre-calculus math course today. Email me here for course materials, class worksheets, homework sheets, videos, PowerPoints. 2.8 part 1, you got 4 points here of notebook taking and 42 points here in your classwork today. Quadratic models, classifying scatter plots. Use scatter plots and a graphing utility to find quadratic models for data. Then choose a model that best fits the data. And today's bell work, teachers, today's bell work for your students is find f of g and b g of f. So you got composite functions here and same thing down here. So students, I'll give you 5-6 minutes for that. Okay, welcome back everybody for your bell work today. A would be f of g and then b would be g of f. So f of g, here's f of g, so you would substitute g into your f here for a for this first one here. So this would go into here. So it'll be 2 times x squared plus 1 minus 1, and then when you simplify, it'd be 2x squared plus 5, and then g of f, now you would put this one into this function here, so that would be 2x minus 1 squared, 2x minus 1 squared plus 3, simplify that, and then you expand this, and then add similar terms. And then you get 4x squared minus 4x plus 4. And then down here for number 2, so f of g, so you would insert this into this function here. So 5 times 2x squared minus 1 plus 8, simplify out here. And then for g of f, you then insert this function over here. So it would be 2 times 5x plus 8 squared minus 1. This is what you get over here when you square that. And then you subtract 1. And you end up with this quadratic over here for that one, students. So that's what you should have. Attach a sheet. You'll probably need more room than what's on this answer sheet. This is your answer sheet, so you'll need extra room to do a lot of your work. Attach a sheet. Class worksheet. Let's get on to page 1 into your notebook. Classifying scatter plots. In real life, many relationships between two variables are parabolic, as in section 2.1. Example 5. A scatter plot can be used to give you an idea of which type of model will be best fit for a set of data. So when you have a visual of what the data set looks like on a scatter plot, you can kind of tell which kind of model, which kind of function will be a best fit to use for that data set. So decide whether each set of data could be better modeled by a linear model. So y equals ax plus b, a quadratic model, this will be linear. This is a quadratic, y equals ax squared plus bx plus c, or neither. So let's see what we got here. This is your set of data. And it continues down here, and it continues down here. So you have about, I don't know, what does it look like? 2, 4, 6, 12, 15 sets of points here. Begin by entering the data into a graphing utility, and then this is what it would look like here once you plot this stuff here within a scatter plot. So it looks like it would be a linear function, doesn't it? Begin by entering data. From a scatter plot appears the data follow a linear pattern. So the data can be better modeled function. So we got B here. This is another set of data. So when you put this thing, enter the data into a graphing utility and then display the scatter plot. So when you display this bunch of points here, you get this. From the scatter plot, it appears the data follow a parabolic pattern. So the data can be better modeled by a quadratic function. This looks like 1/2 of a parabola. So it will be a form of a function. Then see here another set of data. Here's your data points. Enter the data into a graphing utility and then display the scatter plot. So you got something like this. So it appears the data do not follow either linear or parabolic, so the data cannot be modeled by either a linear or a quadratic. So this thing here actually looks a little bit more like a cubic model is what it looks like. So let's try a couple here. Determine whether the scatter plot can be best modeled by a linear or a quadratic. You got this here and you got this thing here. So this looks like linear. It looks like a line would go down through the center of all those plots. And then here, it's just kind of haphazard here, so it would be neither. Page 6 in your notebook entry, fitting a quadratic model to data. In 1.7, you created scatter plots of data and used the graphing utility to find the least squares regression lines for the data. You can use a similar procedure to find a model for nonlinear data. Once you've used a scatter plot to determine the type of model that would best fit a set of data, there are several ways that you can actually find the model. Each method is best used with a computer or calculator rather than with hand calculations. So this is much better than doing hand calculations. By using your graphing calculator and the regression feature. So fitting a quadratic model to data, a study was done to compare speed with mileage in miles per gallon of an automobile. So here's speed, and then here's your mileage here. So the results are shown in this table. Okay. A, use a graphing utility to create a scatter plot of the data. So we need to enter this into a graphing calculator. From the scatter plot, you can see that the data appear to follow a parabolic pattern. So here you see a slight kind of like upper max of a parabola here starting to form here. The middle looks like you have a max somewhere in here somewhere. So finding that out, to use the regression feature of the graphing utility to find a model that best fits the data. So we use a regression feature, and this is what we came up with here. Ax squared plus bx plus c, and then we have a negative 0.00821, 37862, then b, and then c. So that would be our quadratic for that set of data. So the quadratic equation that best fits the data is given by negative 0.0082x squared plus 0.75x plus 13.5. That would best fit that set. C, approximate speed at which the mileage is the greatest. So right about here is your max, and you can do that on your graphing calculator. Graph the data and model in the same viewing window. Use the max feature or the zoom and trace of the graphing calculator to approximate the speed at which the mileage is the greatest. You should obtain a maximum of approximately 4631. So when x equals 45.7, you get a y of 30.64. So the speed at which the mileage is greatest is about 46 miles an hour. Let's go into a guided practice. And this is your plot here for this up here. A, use a graphing utility to create a scatter plot. Let t represent the month with t equals 1 corresponding to January here. So you start here with 1, 2 through 12. And then here are your values here, precipitation. B, use the regression feature of the graphing utility to find a quadratic model for the data. So here is your plot here for it. We started over here because see January, February. Okay, okay, I don't understand. I mean, I think it would start here. January would be 1 and it would go this way, but it looks like if this is the y-axis, it started over here at -2. See, the table shows a monthly normal precipitation for San Francisco. Well, I don't really understand that, unless there's a random axis in here. 0 and 15, it's just kind of a random axes here, evidently. And then B, use the regression feature of the graphing utility to find a quadratic model for the data. So we're going to use a quadratic model. I guess we've determined this looks like a parabola. So a quadratic model will be better, I guess. Use regression feature of the graphing utility to find a quadratic model. Okay, so using the graphing utility to graph the model with a scatter plot from part A. So we're going to do that, and then we're going to use the graph from part C to determine which month of the normal precipitation in San Francisco is the least. So from our data, this is our quadratic that we've came up with. 0.006x squared minus 0.23x plus 10.5. And then using the graph from there to determine which month in San Francisco is the least. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 4, 6, 8, 10, 12. So it looks like, I guess this, what would that be, November? Okay. So that's part 1 of your lesson today of pre-calculus math. Email me here for questions or course materials. Thank you very much.